This is Unit 1, Day 1. We'll be talking about interval notation and reviewing domain and range. So most of these concepts you should be familiar with from last year. We're going to start with just some inequalities on the number line. This first one is asking us to graph or show the inequality that x is greater than -2 and less than 2. So x is between -2 and 2. So on our number line, we just want to show all of the values that are in between -2 and 2. So here is -2 and 2. Our x value is somewhere in between these two numbers. Now, it has also on this side, x is less than or equal to 2. So that means that it is possible that x could equal 2. That means on our number line, we want to fill this circle in to show that it could take on that value of 2. On the other side, though, it's strictly greater than -2. So this one will stay open. This next example, I wanted you to see that it doesn't have to be whole numbers. Here we have a 3.5. So it doesn't have to be a 3 or 4 or 5. It can be a decimal, it could be a fraction, it could be any real number. So in this example, we want to show that our x value is somewhere between 0. So over here, we will show that it's between 0 and it could go all the way up to 3.5. That's about halfway between the 3 and 4. And we'll show that here. So our x value is somewhere between these two. And again, we want to check our ends on this side, on the 0 side. X is greater than or equal to 0. So we want to fill this in. On the 3.5 end, it is not including that. It doesn't have that equality, so we leave that circle open. And this last one is asking us to show on the number line x is greater than 1. So if I set up some values on my number line, I want to show that x is, and it's open this way, that's showing that x is bigger. X is greater than 1. So it's from here and anywhere that's above that, anywhere larger than 1. In this case, that circle is going to stay open because it does not include 1. It's just strictly greater than 1. All right, so all of these examples are showing inequality notation. When we're using greater than and less than symbols, that's inequalities. Something that you learned last year and that we want to review today is called interval notation. It communicates the same information as an inequality, it's just a different way of writing it. Sometimes it's easier to use inequalities, sometimes it's easier to use interval notation, so we like to make sure that you know both types of notation. It's like speaking French and Spanish. If you know both languages, you can communicate with more people. So if we're looking at the example that x is between 2 and 6, it's greater than 2 or equal to 2 and it's less than 6, we can write that in interval notation like this. So it's communicating exactly the same information from 2 to 6, and we use these brackets and parentheses to show if the endpoints are included or not. So on the left side, since that could be equal to 2, we use the square bracket. That means that the 2 is included. And on the other side, it's not equal to 6 or can't be equal to 6, so we use this parenthesis to show that the 6 is not included in the interval. So this is saying it's the interval from 2 to 6, including 2, not including 6. And those are the symbols we that we'll use for interval notation. The parenthesis means that it's not included or open, and the square bracket means that it's included or closed. So we'll practice a couple of these. Our first inequality is from the very first slide, so we already practiced graphing that. X is between -2 and +2. Doesn't include -2, but does include +2. So we have an open circle on the left, closed circle on the right. So for interval notation, you can almost think of it like reading that picture from left to right, just like a sentence. So it starts at -2, goes up to +2, and we are including the +2, so we use the square bracket on the right, and it didn't include the -2, so we use the parenthesis on the left. All right, so now we have an interval from 2 to 5. We want to make a graph of that, and we want to write it as an inequality. Well, the interval from 2 to 5, we can show it on our number line. Whoops, sorry. Pen. 0, 1, 2, 3, 4, 5, 6. So we want to show from 2 up to 5. Here's our little graph of that. And in this case, we have a square bracket here, so we would like to include the 2. It could be 2, so up, starting at 2, could be 2 all the way up to 5, not including 5, because on this side we have an open parenthesis. If we need to write that as an inequality, you can almost think of it as that this is giving you the two ends. It's saying that x is between the 2 and the 5, somewhere in between there. And then we just need to get our symbols right. Well, on the left side, it could include that, so it's greater than or equal to 2. And on the right side, we have the 5, and it has to be less than 5. On these compound inequalities where it's between two numbers, these symbols are always going to point the same direction because it's showing x is in between these two. It has to be bigger than one of them and smaller than the other to be in between. So they should point in the same direction. All right, our last one, we have the inequality -6 is less than x, which is less than -3. So on our number line, let's see, -7, we'll get this set up. And we want to show that we have an x value in between -6 and -3, somewhere in here. And in this case, if you look at these inequality symbols, neither of them are included. They are both going to be open circles, so our graph is complete. And now we just need to write that in interval notation. And in this case, if we read our picture from left to right, it starts at -6. I used a parenthesis because it was not included, and it goes up to -3. Another parenthesis on the other side because it is not included. Brief aside, sorry, this looks an awful lot like if I had a graph -6, 1, 2, 3, 4, 5, 6, and down 1, 2, 3. It looks a lot like this point, -6, -3. So that same notation with parentheses and numbers, it could be indicating an interval like this is. This shows the interval from -6 to -3, or it could indicate a point, the point -6, -3, where you go back 6 in the x direction and down 3 in the y direction. And this is just like in language arts when you have two words that are spelled the same and pronounced differently, like tear, like I'm crying, or tear, like I had a piece of paper and I ripped it. So you know which one is which just based on the context of what you're doing. As you're reading a sentence, you can tell which word it should be. And that's the same thing with this notation. If I'm talking about a domain and I see this, I know that it's talking about an interval from -6 to -3. If I'm talking about a solution to a system or a problem in context, I know that what it's talking about is that specific point on the coordinate plane. So it does look identical, but by taking into account the context, you can know which one you're talking about. Okay, so what about if we just have one restriction? So before we always knew x was between two numbers. Well, in this case, we just know that x is, and this symbol is greater than, x is greater than 3. We looked at this graph earlier as well. So if x is greater than 3, I've got this open circle on 3, and I know that it's somewhere above that. It's some number that is larger than or greater than 3. So we have the inequality, we have the graph. In interval notation, we want, again, to sort of read this picture just like we're reading a sentence from left to right. It starts at 3 on the left. I used an open parenthesis because it is an open circle there. So from 3 up to, and it's got this arrow showing that it's going and going and going and going. And so we say that it's from 3 up to infinity. When you're using that infinity symbol, you always use a parenthesis. We don't include infinity. Infinity is more of a concept than it is a specific number. So we can't include it. We just want to use that open parenthesis. So there's these two different situations you may have. If it includes all numbers greater than a certain number, it's up to but not including infinity, you may have some number here, 5, 3, 7, from that number up to infinity. That's always going to look like a picture, or the graph of that will always look something like this with an arrow going to the right. Or you could have infinity on the other side. You could have a situation where it's everything to the left of a certain number. And in that case, if you're reading it from left to right, it would be from negative infinity up to that certain number. So let's practice a couple of those. So this first one, x is greater than 3. I feel like that's what we just did. How silly. Yeah, it is. Good times. So if we read it left to right, it's from 3 up to infinity. And again, with infinities, you always use the curve parenthesis instead of the bracket. This next one down, we have the graph. It's showing that our x value could be anything less than -3. Our interval notation is from left to right, so it's from negative infinity up to -3. And since it was a filled in circle, we know that we want to use a square bracket to include that value -3. So if I want to write that as an inequality, again, it's everything. Everything here is showing is less than -3. So we want to write x is less than or equal to -3. All right, this last one is asking us to graph and write in interval notation the inequality x is less than 0. So if we fill in our number line, here's 0. Our x value is less than 0. So we will show everything to the left of 0, basically all the negative numbers. And if we write that in interval notation, it would be from negative infinity. I'm starting on the left, just like a sentence, and all the way up to 0, but not including 0. So we use a curved parenthesis after the 0. This page, it's in your notes as well. It kind of just shows you a lot of the different scenarios. It's just for your reference. In each of these cases, it shows you what the interval notation is and the inequality notation. So this one happens to be open on both sides. It's not including either of the ends. And then it gives you a little example of that, and it shows the interval notation and the picture of the graph. So again, this is just for your reference if it helps you later when you're looking at your homework. Okay, so now we have a different type of interval. This interval is different from the ones we've done before because it has basically two parts. So in this example, it shows me that my x value could be over here less than 1, or it could be over here greater than 4. And it has two parts. Well, the picture has two parts, so the inequality is going to have two parts. It's almost like you could forget about part of this for a minute. We could just completely forget about this half for a second. We've got this piece over here. It's showing that x is less than or equal to 1, and our inequality is also going to state that x is less than or equal to 1. The other half, or the other part I should say, is showing that, whoops, sorry. The other part is showing that x could be greater than or just greater than 4, and it wants to put it in the box. That's funny. There, I'll just make it, whoops, I'll just make it bigger. So here's the picture showing x is greater than 4, and then our inequality that goes with that is that x is greater than 4. These two go together. The interval notation is the same. It's in two parts. So we just need to make sure we're showing both of those parts in our interval notation. So we want to show that x is greater than 4. Well, that's right here between 4 and infinity. X is greater than 4. And then that first part that we looked at first, showing that x is less than or equal to 1, our interval notation shows that as well. X is between negative infinity and 1. This union symbol is a mathematical symbol that just means or. It's the reason that it's a U is it's for the word union, but it means or in math. So we have the interval that from negative infinity to 1 or from 4 to infinity. X is in one of those two parts. So here are a couple to practice. If we graph this first one, -5, we'll set up our number line. We want to show that x is less than -5. So that's to the left of -5. -5 on over. That doesn't look very open, but it's meant to be open. And then the other part, we've got two parts in our inequality, so we're going to show two parts on our graph, is that our x needs to be greater than 0. So our graph looks like this, and neither of those are filled in because they are both strictly greater than or less than. There's no equal part of that. They're both open intervals. So in interval notation, we can read that picture just like a sentence from left to right. It starts over here, it's going towards negative infinity, all the way up to -5. Or, so use my union symbol, it could be between 0 and infinity. This second example has the interval notation for us. We need to graph it and write it as an inequality. So that first part, I'll graph in blue. It's from, let's set up a number line, -2. So I want to show that x is less than 0 from negative infinity up to 0 there. That's that part. And then this other part starts at 2, and I'm filling that in because of that square bracket tells me the 2 is included, and we go all the way up to positive infinity, so I show my arrow going up towards infinity. So there's our graph. And now we can show the inequality. Again, we can do the two parts. So this part of it is showing that x must be less than 0, not included. Or the other part is that x could also be greater than or equal to 2. When we did compound inequalities, you might have noticed that those symbols were going in the same direction. When you're talking about these inequalities that come in two parts, greater than one, less than the other, the symbols, the inequality symbols are usually going the opposite directions if your variable is coming first. So if that helps you to remember, you can use that. All right, this last one, we have the graph. We need to write the inequality and the interval notation. So let's write the interval notation first. We want to read it left to right. So it's from, starts at negative infinity, goes up to the value 3. This is included, it's a filled in circle, so it includes the 3. Or starts up again at 4, that's included, and it goes up to infinity. So there's our interval notation. And now we just need to write those two parts as an inequality. So the first part, we can look at this side. Oh, this is kind of backwards maybe, but whatever. X is greater than or equal to 4. And our other side, we'll look at it in red. This side is showing that x is less than or equal to the number 3. So we have our two parts of our inequality. All right, one last type of inequality that I want to talk about today. How could we represent an interval like this? This is stating that x cannot equal 5. So any value of x is fine, it just cannot be 5. So if you think about it, it's almost like it includes every single number. It's almost like having a completely filled up number line. Everything's okay. Yay! We could have any of these values, except we have one small problem. So on the graph, we just put a circle around that one value that x cannot be. It could be anything over here. It could be anything over here. It cannot be 5. X cannot be that value of 5. So this graph shows x cannot equal 5. The interval notation is in two parts. It's almost like you want to think about a part over here and a part over here, and we write those two parts separately. So we have this part over here from negative infinity up to 5. The 5 is not included. And then we've got this part over here. It starts at 5, but the 5 is not included. And it could from there go all the way up to infinity. It's almost more cumbersome to write it in interval notation than it is in inequality notation. But you know, sometimes when we're working in interval notation, we just want to stay in interval notation. So here's our interval notation: negative infinity 5 or 5 to infinity. The 5s are not included. Let's try a couple of these. So we have the inequality x cannot equal negative 1, so any value is okay, except we can't have the value negative 1. So we have a circle over the negative 1, and we show that anything else is okay. So for interval notation, if we write that left to right, it's from negative infinity up to -1. Again, you can think of it like these two parts, or from -1 up to infinity. For the second one, it's showing that, let's put a number line, let's see. The second one is showing from negative infinity to 0, so everything over here, or from 0 to infinity. So that would be this side. It's showing us that x could be everything except the one value that doesn't work is 0. X cannot equal 0. The last one shows us a graph, and we want to write it as an inequality and in interval notation. For the inequality, looks like we could have every single value except the only one that has a problem is 4. X cannot equal 4. And in interval notation, we need to write these two parts. We've got this part and this part. So it's from negative infinity up to 4, or from 4 to infinity. Neither of those 4s is included because we cannot have our value of x be the number 4. All right, so the whole purpose, well, maybe not the whole purpose, the main purpose of interval notation and inequality notation is that we can communicate restrictions, and a lot of times the restrictions that we want to communicate are in the function's domain and range. We want to be able to tell or communicate to other people what the domain of a function is, or we want to communicate what the range of a function is, and so we need some sort of notation to communicate that with, and we'll communicate it either in interval notation or as an inequality. So we're going to switch to domain and range now. So domain, if you think back to your other math classes in the past, you hopefully remember that domain is the x values that a function or a relation covers or includes. They're all of the x values. And when you're thinking about domain, you want to think about it, again, like a sentence from left to right. And you know, the main reason that it's from left to right is that we start with our small values or our negative values, and we want to go up to our larger values. So that on the x-axis is from left to right. Range then is our other dimension, our other direction. It's the y values. And when you're thinking about the range, just like with the domain, you want to think about it from those negative values or smaller values up to the larger values. So if you think about a coordinate plane, we've got like the negative numbers in over here in the x direction and the positives here. So we read from left to right. In the y direction, our negatives are here and our positives are here. So we want to read from bottom to top. I always say, helps me remember, bottoms up. So always from the negative towards the positive, or from the lower values to the higher values for the range. So let's look at this little zigzaggy function. If we want to write the domain of this function in interval notation, domain is focusing on those x values. So don't even, that's funny. Don't even think about the y values for a second. Just focus in on those numbers on the x-axis. If we're talking about the domain of the function, well, the very farthest to the left looks like it's -6. And the very, very farthest to the right looks like it is the number 5. So we're talking about the interval from -6 to 5. And if we want to think about whether those ends are included or not, well, it looks like my graph is showing a closed circle on both ends. So we would use brackets to indicate that both of those values are included. So now we want to think about our range. Range is all about those y values. So we're really going to focus in on our y-axis. All of these numbers. And for this particular function, if we're thinking range bottoms up, our very, very lowest value happens right here. And on the y-axis, that corresponds to 1. All the way up to our highest point on the function corresponds to a value of 6 on the y-axis. So our range is from 1 to 6. And again, it's coming down and touching those points, so we're going to include those on both sides. So we use brackets. From 1 to 6 is our range. Let's write that same domain and range as an inequality. So again, our domain covered from -6 to 5. So as an inequality, we know that x is between these two values, and it's less than -6 is less than or equal to x, or x is greater than -6, and x is less than or equal to 5. So between -6 and 5. Again, both of those are included, so they have the equal part of that symbol. For the range, tricky stuff here. The number one mistake people make with range is that it's a y, not an x. And I do it all the time myself. I'll usually catch myself, but I'll start writing an x for that. But range is focusing in on y values. Let's erase this. So again, it was from 1 to 6. So if I'm writing that as an inequality, I want to show that y is between 1 and 6. Y is greater than or equal to 1, less than or equal to 6. And again, when you write these compound inequalities, those two symbols should be, they're facing the same direction. They're pointed the same way. All right, so we have 4 graphs. We're going to do the first 2 domains and ranges in interval notation, and then we'll do the second 2 in inequality notation. So for this first graph, the domain, remember with domain we focus on x values. So for this function, if I'm focusing on the x-axis, it looks like the function has a domain from -2 and all the way up to 7, -2 to 7. And for our ends, we've got to think about whether they're included or not. On this side, we've got that open circle, so we do not include -2. On this other side, it is a closed circle, so the 7 is included. For the range, and these can be a little tricky, especially if it's been a while, but you'll get the hang of it. We'll keep practicing. So for the range, we're focusing on y values. So don't even think about those x's anymore. Think about these y's over here. For our range, and we remember with range we go bottoms up, the lowest value corresponds on our y-axis to -1. That's an open circle, so it is not included, it's parenthesis. And our very highest value, tip top, on the y-axis corresponds to the value 2. That's a filled in circle, so it is included. So the range is from -1 to 2, including the 2. And just make sure you really focus on the y values for the range. For the second graph, we have kind of an interesting thing. It's got 2 parts. It has one distinct part, and then it has a gap, and then another part that looks an awful lot like a parabola. or at least part of a parabola. So if we want to know the domain of this function, well, if the function is in two parts, we've got a part over here and a part over here, our domain is also going to be in two parts. We've got this gap right here that has no function above or below it. Okay, so the domain, if I'm focusing in on x values, this function has a domain from, well, it's got an arrow over here, so that's going to be negative infinity, up to, and it reaches this value right here. That x value is 0. It's kind of tricky because there's not a 0 there. There's a lot of 1s nearby, but the zeros aren't typically written, so you have to catch that. It's 0. And then we've got a whole lot of nothing, or we use our union symbol, or our x could be over here, starting at 2, and that's going to be a bracket. Sorry, I wrote a parenthesis there before I even looked at it. That's a square bracket. It includes 2 and goes up 2, and it's going up and it's going out farther and farther out. It's going to go to infinity. That thing is going up a lot faster than it's going out, but it will keep going out to the right. All right, for the range of this, we have to focus in on the y values. Don't even think about those x values anymore. For the range, you want to focus on the y value. So our range is, well, if we're reading it bottoms up, always start with the most negative value. This has an arrow pointing downward, so it's from negative infinity up to, well, this value that it went up to is 0. Or we have a second part. We've got this gap right here. Let's see. This gap that isn't, there's no part of the function in that gap, so we want to leave that out. And then it starts up again with the y value 1, and that's included, and that goes up to infinity. So from negative infinity to 0, or from 1 to infinity, and the 1 had square bracket included. All right, so there's two graphs with the domain and range in interval notation. And some of these graphs are a little bit tricky, but we'll be using interval notation throughout the year, and you'll be an expert soon enough. All right, so these two we're going to write in inequality notation, which I think is a little bit trickier. For this first graph, it's showing the graph of an absolute value function. The domain of this is, and in class a lot of you said, because you remember, it's negative infinity to infinity. And that's true. It is from negative infinity to infinity. The farthest to the left is negative infinity, and the farthest to the right is positive infinity. In both directions, it's going to keep going. But that is interval notation, and I would like you to write it in inequality notation. And we didn't review this yet, but you'll hopefully remember from prior years. It's basically saying anything is fine. Negative infinity, positive infinity, anything goes. We have no restriction on an x value. It's any number. And the mathy way of saying that is this symbol. It's a capital R with 2 bars. And that symbol, you probably remember, means all real numbers. So the domain of this absolute value function is all real numbers. The range is not all real numbers. If we think about range from bottom to top, this graph is only covering certain values. It does not go below -2. So we would write that as a y, because it's a range, it's not an x value. You'll find yourself writing x's for those, and we'll try to catch them and get in the habit of a y for range, but it is pretty tricky. Sometimes the x just comes out of the pencil. So y, and all of these y values are larger than, greater than, or equal to -2. So our range is y is greater than or equal to -2. Last one, hooray. So we've got this squiggle and another squiggle. It's got a little break in between. Sometimes when it's stacked like this, where you have an open circle directly above or below a closed circle, it's called a jump sometimes. So we've got a function that's closed circle, squiggle, open circle, jumping down to 1, and then it does a little bit more squiggling. For this domain, it looks like, and I'm going to kind of draw it on the x-axis as if it was a number line. It starts at -2, it goes up to 1, open circle, and then closed circle on top of that, all the way up to 4. So you can see that if you kind of draw it this way on the x-axis, you can see that this closed circle sort of fills in this open circle in the x direction. So our domain, even though it looks like it might have 2 parts, it really only has 1 part, from -2 to 4. And the -2 is included and the 4 is not included. It's not necessary to break this up. It's really continuous in the x direction. And now let's look at the y direction. So with the range, we want to always remember to go from the lowest point to the highest point. So in this case, for this function, the lowest point looks like it's down here at the y value of 1. And it's touching that 1. It's included. And the highest value is 3. It hits that value of 3 a couple of times. And also included. And now you might be thinking, wait, what about this thing right here, this gap? Well, it's true that it does have a gap, but for range, we're just talking about all the possible y values that the function covers. And even though there's a gap here, that section is covered here, and here, and here, and here, and here. So it definitely has got that 1 to 2 section of the y-axis covered. So even though there is a gap here, these other parts sort of make that an okay part of the range. And that is our last example problem. So today we reviewed inequality notation and interval notation, and we practiced identifying domain and range of some functions in both notations. And the homework assignment should be in your notes packets. It's a pink colored paper. There aren't any answers on that worksheet, but I will post answers on my website if you would like to check your work as you go, or at the end of when you finish your work, just to make sure that you didn't have any issues. So that's it for this lesson. Thank you.